For this video, we're going to look at what happens when the base of our equations are absolute values. And again, our exponents are going to be the same, and we're really going to be playing around with what numbers we have here. I also wanted to look into what happens when this doesn't always equal 1. So we're going to also look at changing this number as well. So just to get started, we're going to just do 1, and we see that nothing really happens. We're also going to change this to 1 just so we can get an idea of the basics, and then we'll start playing with it more there. So we see that we have this just perfect rhombus going on, and this is probably to do with the fact that the absolute value sign in and of itself follows a similar fashion to half of this shape. And that would be my conclusion as to why this is created. So then looking at 2, we get the perfect circle. And this just makes sense because regardless of what you put here, that squared is gonna get you your circle. And then this is different, however. Typically, when we saw that we had an odd equation, we had that curve going on. And here, obviously, there's no curve. There's a closed figure, and even though the exponent is odd. So we'll just see if this pattern continues. Again, we see the 4, which is similar to the 4 that we saw, the exponent 4 that we saw at the beginning of this exploration. And really, I don't think that the even exponents are going to be affected by this absolute value base, because whether you input a negative or a positive number, the outcome is always going to be positive. So I think that's why that when we see these new figures with the absolute values as the base, the change is non-existent for that of the even exponent. So for that reason, we're really just going to be focusing on what happens with our odd exponents and why that might be happening. So looking at our 5 here, we notice that again, there is no curve that would have originally been around this area, but we have a closed figure yet again. So just going through and sliding and just kind of seeing in general, we don't have any open curves. We have no openings. They're all closed figures. And my opinion on that and conclusion from that is just that in the other graph, when we didn't have the absolute values, the negatives had to be taken into consideration. So when you input a negative x or a negative y, you're going to have a different outcome. But here, the exponents can basically be equivalent to even exponents, not in the value that they produce, but more so in the sign that is accompanied to their outcome. So that is what I noticed in this part of the exploration. But I also wanted to look at what happens with the negatives and if those exponents followed any similar patterns. So my prediction was that since we saw that the odd exponents followed a pattern of the even exponents, that the same thing would occur with the negative exponents. So just going through, we see that right off the bat, we have the 2. And again, that like cross shape is formed. And then here at -3, again, this cross shape is formed. So just continuing to look at the pattern, we see that it does indeed follow that of what an even exponent would look like. So from this, we can conclude that when the base is an absolute value, that the exponents are going to act the same way as the even exponents. However, 1 is a little different because in the original equation, x to the a plus y to the a equals 1, that was actually a line. So this is probably the only equation where there is a difference in the patterns. But I think that this just helps you see that the pattern goes from, this into this, and so forth. So now we're just going to look at what happens when we change b here and what happens. So for the even exponents, this probably just means that the shape they've created is just going to get bigger and bigger. And since we've already concluded that the even exponents and the odd exponents are going to have a very similar behavior, I would predict that the odd exponents are also just going to grow as b increases. So we will test that. But just to show you that this happens for all the evens, we see that it just continues to grow. Maybe just not as a fast rate, but it does still grow outward. So now let's look at an odd function. So here we have the 7, and again, as b increases, so does the size of the shape. And now just to continue to look at this pattern, we see if that applies. So again, the rate at which the figure grows is not as rapid when these are smaller, but for the positive integers, at least the positive exponents, at least we see that it continues to grow. Now let's check out what happens at the negative exponent. So we're just going to move this back like so. We're going to see what happens when we change this for the evens first, just to see if we can spot the pattern between the even and the odd, knowing what we do. So here we see that it's actually shrinking towards the middle the greater that b becomes. And we'll see if this applies for the other evens. And we see that it does, in fact, continue to shrink in towards the origin. Now, just the question is, does this happen for the odds as well? So we see that here it is more inward, but just to further show you that that happens, the greater that b is, the more towards the origin the graph behaves. And just to continue to show you this for all of them, that happens.